So, over the next half hour or so, we're going to go through what it's like to develop applications using Cloud Foundry. We're going to cover some basic commands and some tools that you can use to make your life easier. We're going to cover some basic concepts, look at specific tips and techniques that will help you develop applications so that you can get the most out of the platform. And we're also going to cover data stores, databases, how they integrate with Cloud Foundry, and then we'll finish with some logging and debugging. Before we start, who are these two strangers that are here tonight threatening to talk about Cloud Foundry? So hi, my name is Maria, and I work for Pivotal. I'm specifically in the team that integrates Redis with Cloud Foundry.
I'm Jatin. I work here with the backup and restore team.
All right, so what is Cloud Foundry? In a nutshell, you can think of it as a tool that you can use to get your application and deploy it, have it running somewhere on the cloud. It's a little bit more involved than that, but really what we need to know as developers is that it takes away some of the common pain points that we face. One example is that it makes it really easy to scale applications, be that in number of instances or in resources. It also makes it really trivial to have an exact replication of your environments. That means that your development environment will be exactly the same as your staging, CI, and production. So a common problem that I used to have was that I would develop my code in an environment that's slightly different from the one where the code would end up. And sometimes you would have situations where you need to debug issues that have to do with this slightly different setup. So to offer all of that, the platform requires a specific style, a specific design for applications that are deployed onto it, and we're going to touch on that as well.
All right, so what is Cloud Foundry? So Cloud Foundry by itself is an open source software. You can download it and install it. All the sources are available for free. But normally, as a developer, you would never have to install Cloud Foundry yourself. The ops team in your organization will probably have deployed it for you. So there are two main ways people deploy Cloud Foundry. The first one is on-premise, in which you buy hardware or buy an AWS account and deploy a Cloud Foundry on top of that. There are a lot of companies like those who brand Cloud Foundry and provide support for Cloud Foundry, from which you can buy instances of Cloud Foundry to deploy on-premise. The other option that you have, if you have just a limited number of applications to deploy, or if you are trying out Cloud Foundry and don't want the cost of like buying hardware, is use it as a service. So you could go to one of these sites and create an account, and when that account will essentially give you a login in which you can push your applications onto their servers to run it. So if you're just evaluating Cloud Foundry or would like to try it out on your workstation, there is one more option, which is Pcf Dev, which is a Pivotal product which condenses Cloud Foundry so that it can run on your machine. So it's a Vagrant box which has all the components in it. It takes around 10 minutes to set up. So this is what we are going to use for all of our demos as well. So, which brings us to the next section of our presentation, which is how life looks like in a day in the life of a Cloud Foundry developer.
Right, so imagine this scenario. You've come in to work in the morning and you've had your favorite caffeinated drink, and you walk in a meeting with your project manager, and apparently your new assignment is to create a web application that lists beers. So you go back to your desk, you have a first chat with your teammates, and you decide to deploy it as a basic kind of Ruby application. Fairly quickly, you come up with the first version of it. So all this does is expose one endpoint. And what happens when we hit that endpoint is that we get this HTML page that just statically lists a few favorite beers. OK, so that's a very good first step, and we can go ahead and deploy that. The only thing that would need to change in Cloud Foundry world is this instruction of how the application starts. And instead of saying started on 8080, we say read what port Cloud Foundry chooses for you through this environment variable called port, and start it on that port. Now this is important for a couple of reasons. So this port is first of all where Cloud Foundry will start the application. That means this is where it's going to route any traffic once the application is up. Secondly, this is where it's going to perform any health check. So if the TCP port is not open, then the deployment is not considered successful. Okay, so to deploy an application to Cloud Foundry, we do that with a command called push. So we do a cf push and the application name from our code directory. And then a series of exciting events happens. The first one is that the command line that we're using, the cf CLI, essentially zips our code and sends that to the Cloud Foundry installation, which in our case just lives on our laptop. Once Cloud Foundry has that code, it's going to run a set of diagnostic scripts against it, which are called buildbacks. And their purpose is to identify what the application is written in. So in our case, it's going to find out that it's written in Ruby. Once it knows it, it knows how to build it. And then the next step produces an executable package, which is called a droplet in CF lingo. And this droplet is then going to be deployed into an application container. Once this finishes, Cloud Foundry is going to start hitting the port that it chose. And once this port starts responding, it will consider the deployment successful. And it's going to return to us a route that it registers. And this is the one that we can use to hit the application ourselves. So there we go. Like magic, we have a first version deployed. That's right.
So, hello. Yeah. So the first thing that I like to do after I deploy an application to, say, the internet, is to measure how much traffic the application is getting. So one of the tools that I like to use for that is like the Google Analytics tool, so in which you essentially inject a tag in your code, which will measure every time somebody visits the page, you'll measure that view. So over here we have a snippet in which that tag is injected into our page. So one piece of configuration that I need to provide for Google Analytics to work is my account, like so my Google Analytics account, so that it routes the traffic back to my account. So the way that you would do this in a typical Ruby application is probably read it from a configuration file, that piece of information that you need to link to Google Analytics. What Cloud Foundry asks you to do is, rather than reading your configuration from a configuration file, try to take it from an environment variable. So all the configuration is is preferably read from environment variables. So over here we have an environment variable called GA_tag, and this is where the information for our Google Analytics tag is going to come in. So how do you set that up? So if we go back to the console, we can set this environment variable up with a cfn command, a cfsetend command. So you go like cfsetend, the application name and the tag. So if you do that and like actually see our application, we see that our tag is injected into our page, and my Google Analytics tag has my ID in it, so that can route traffic. So this just shows us how to configure applications. So you configure applications through the environment. So if you want to see what environment variables you have set for a particular application, you can ask Cloud Foundry the environment for an application. So you go like CF, and we are in this case, and this will show you that there's just one user-provided environment variable right now, which is called GA tag. So cool. So So our manager is back, and apparently the application that we deployed on the internet has gone viral, and we are getting a lot of load. How can we possibly handle that?
Yeah, I mean, there's two main kind of load scenarios that you would face in real life. The one is that you're getting many requests and not enough service to serve those requests. The other is that your application is struggling with the resources that it has available. And equally, there's two main ways that you can deal with them. So you can either simply give more resources to the server that's running, to your infrastructure that's running the application, so more disk or more memory and so on, which is also known as scaling up. Or especially in the scenario where you have a lot of requests, what you can do is simply have more instances of your application serving those requests, which is also known as scaling out. We can try and get a kind of a feeling what's happening with your application by doing CF app and the application name, and that will tell us how much the CPU is working. Here it's not very much, but we can imagine that with a lot of requests we would have a high CPU utilization. Now, because this is a high request issue, we're going to go ahead and scale the number of applications. And what's interesting about Cloud Foundry is that we as developers don't need to do absolutely anything at all with our codes. All we have to do is go to Cloud Foundry and say CF scale -I for instances and the number of instances that we want to have. And that is about it. What happens now behind the scenes is that Cloud Foundry will first create the additional instances that we have requested. It will take care of any discovery or any root registration between them, and it will also arrange any load balancing that needs to happen. So whenever a request comes in, it will take care to load balance it between the servers. If we go back to our page, we have added this line at the very bottom which says which of the 5 instances is serving this request. And if we make a lot of requests, we will see that index change as a specific container changes as well. Okay, so that's all very good. We've dodged that bullet, but unfortunately our website is still quite static. And our project manager comes back and says that we need to drive user engagement by having users add their own beers if they so like.
Yep. So how would we make our website more dynamic? So we can probably accept some user input and try to display it back. So after we accept the user input, we need to save it somewhere. So as we mentioned before, the applications actually run inside containers, and you're supposed to treat the storage on the local machine where the application code is running as ephemeral, so it can be deleted at any time. This is because this allows you to scale your containers independently of your code, which means that you can scale compute very easily. So where do you store your data then? So the place that you store data in Cloud Foundry terms is called a data service. So what you would do is connect to a data service to store your data externally in that service. So what we have done right now is modified our application to connect to arbitrary database. So where would we get a database from? So in Cloud Foundry, you can see there is a command called CF Marketplace, through which you can see the available database that you have on your Cloud Foundry installation. In this particular Cloud Foundry installation, which is Pcf Dev on your local machine, it comes with 3 databases. So you have a MySQL, Rabbit, and Redis, and you can see various plans for that. So we can go ahead and create a database or provision a database instance for us. So the way that we do that is go CF create service, a database and a plan, and you have to name the database something. And with that command, you essentially provision a database instance for yourself. So let's take a moment to recognize what has happened here. So in the previous organization that I used to work for, if I wanted a new database for myself and my application to use, I had to send tickets and wait for 3 days and follow up. So what Cloud Foundry allows the operators to do is automate their workflow, so that when I say I would like a service, this goes in and provisions a service for me so that I can consume it. So it drives self-serviceness. So the next step probably is to attach this database that we have created to our application. So the terminology in Cloud Foundry for that is called binding. So what you do is bind the service that we have created to our application. What does bind mean? So bind means that the credentials to access this database or this service are injected into our application, and the way configuration is injected into applications in Cloud Foundry is through the environment. So when we bind the service, it will essentially inject the secrets for my service into my application's environment. So if you go back to the code, what we see is from the environment, we read a particular environment variable. In this case, it's database URL. So the Ruby build pack populates a special database URL variable for us so that we can access the database. We have some basic code to connect to a database, and we have another endpoint to receive requests for more beers. And in the HTML, yeah, we have added a small snippet to actually accept new beers. So if we go back to our data, if you go back to the HTML, and if we refresh the page, we will have an input box. And we can add new beers to that application. So like what you notice now is all the 5 servers are connected to the same database and are reading the data from the same server. So the other thing to note here is like the database URL variable that was populated was special to Ruby. So a generic way of populating variables or giving configuration to the application is through a variable name called vcap services. So if you inspect the environment for the application, there is a special environment variable that is populated called vcap services. So this is a generic way of giving your credentials to the application. So if you see over here, you will have like the MySQL URI. So if you have like a MySQL client, you can actually use this URL to connect to your application to debug, for example. All right.
Okay, good. So we're in a pretty good state in terms of functionality now with our application. It's time to think a little bit more about what happens in the future. So how do we manage output from that application, or how do we debug it? The first thing we would like to look at is how do we do logging? Now, traditionally in an application, you would probably have maybe a log file that you open next to where your code lives, and then when something significant happens, you might want to write a line in that new file. So in terms of code, initial state might be something like that. You open your log file at the beginning of the program, and then you add log lines every time you want to log something important. Now, this is a little bit risky when it comes to cloud applications. First of all, because if that specific server that hosts the file goes down for any reason, you are at risk of losing your logs. Secondly, it gives all the weight of kind of aggregating logs from different instances and streaming them somewhere else. It makes this weight fall all on the developer. So it's extra work for you. In a Cloud Foundry world, the recommendation is that there are no files involved and that the application needs to output any logs that it needs to output onto standard out. So the line that initializes a file goes away, and everything that writes to that file can be simply replaced with a put for Ruby or a system out print line for Java. And that's really about it. So if we go ahead and push this version of the application, it will start working and taking advantage of that functionality that Cloud Foundry offers. And it's not only that it makes it easier for our code and cleaner for our code, but Cloud Foundry will also aggregate the logs, will stream them in real time, can even be configured to forward them on into a third-party log drain, such as Papertrail or Logragator for Datadog. There is a command called cf logs in the application name, which will give you real-time logs for that application. So if we start it and then we go ahead and make some requests, we can then come back and look at what's happening in our application. Exceptionally interesting. Okay, brilliant. So this is how logs work. And they're not only helpful for happy paths, but imagine that you've introduced a bug, as we have done in this last version of the application. So the code in line number 5, if I can say that right, will raise an exception unless something happens. So if we try to push this version of the application now, and give it a time to do its thing. I wonder what's going to happen. It it will eventually attempt to start it and attempt some more. And eventually fail. So logs can be extended with --recent. When we cannot see the real-time logs for the application, we can see what happened just before the application exploded. So if we go ahead and fix that bug, then we should be able to start our application. So we just set the environment variable that was required. And that should now be able to start without any without any big issues. Okay, so we saw how we are able to see logs either in real time or just before a specific event. The last bit that we would like to cover is what happens when logs are not enough for me to debug something that I want to find out more about. So a very good example of this is, for example, network setup or networking issues. And Cloud Foundry offers a command called SSH, so CFSSH, the application name and the container index. And that will literally open a session on that specific container. From there, you can run commands that let you know what happened on that box. So we can ping Google, or we can say, show me what the environment looks like, and so on and so forth. So that's an additional kind of tool that helps us debug issues apart from logs. And that, I believe, is the end of our day. Is it? Yeah. Brilliant.
Yeah, so what we have done is like shown you the basic workflow from Cloud Foundry. So CF push is how you deliver your code to Cloud Foundry to run. CF set env is how you can set the environment and configure your Cloud Foundry application. CF scale allows you to increase the compute available for your application. CF marketplace is where you can see the services to which you can bind to. And create service, bind service allows you to store data. CF logs and CF SSH help you to essentially debug your applications if something goes wrong. So the type of applications that we described right now, like where the logs are sent to standard out and like nothing is written to the disk, are like grouped together and called 12-factor applications. Like hopefully we have given you enough material to like go out and try Cloud Foundry and do CF push your own app.